To create a spade rudder, the first thing we do is start with our design. So we already have it in RhinoCAD here. You can see the top view, the perspective, and perspective is shaded in this case. We can make sure that the post area here is not going to actually extend past the skins. From RhinoCAD, we go to Visual Mill, which creates the instructions for our CNC machine. Here we can simulate the milling, the outside of the core, and of the inside. There we are creating the channel for the post. The whole core is out of a structural foam. In this case we're using Divinicel H80. First we mill the inside of the core for the rudder post. This is our milling software running on the workshop PC. Back to the milling machine. And here is a post freshly created in the mold. Now we've flipped it over and we're milling the outside. You can see in this case the core is being cut away completely where the rudder post will be making contact with the skins. I can't imagine shaping rudder cores by any other way. The core is built up in this case of a slice of 1 inch with a slice of 1/4 inch on top, just to give us the required thickness. And here we have the finished foil ready to take off the machine. The two halves are now ready for gluing around the post. There are many ways of doing the internal web. Some use G10. In this case we will be wrapping unidirectional S-class around the post. The rudder core is now being all covered with epoxy, thickened epoxy, and the post has been wrapped with S-class. We're ready to join the halves. And finally we've joined the halves together with lots of epoxy and put some peel ply and breather over the top and put it in a vacuum bag so the two core halves are being closed together under vacuum pressure. Okay, here we are ready to laminate the rudder. Now that the cores have been joined together, you can see on this one the post is actually making contact with the skins. Very strong way to build a blade. We start by wetting out the core with some thickened epoxy that fills all the cells in the foam. The cloth has been placed over the rudder. The first layer of cloth is a 17-ounce biaxial, which means it's cut with the fibers at plus or minus 45 degrees. As you can see, it's going to wrap entirely around the leading edge of the rudder. We simply pour on some mixed epoxy and force it in with squeegees. The next ply on this rudder is a unidirectional S-glass, so the fibers are running straight up and down, resisting the bending loads. Finally, we place the third ply, which is another 17-ounce biax. This side of the rudder is now done, and we're going to place peel ply and breather on it. Peel ply first, which is a treated nylon. Breather is a 4-ounce cotton that distributes the vacuum pressure and absorbs excess resin. We've placed the plastic sheeting that will serve as our vacuum bag, and we're about to flip it over and do the other side. This side is now a repetition of the first side, starting with wetting out the core with the thickened epoxy as before. The second side, first ply has just been fully wetted out, and as you can see, we've taken and wrapped from one side to the other around both the tip and the leading edge. The last ply has been wet out, and the material is being tailored around the top end now, as well as around the tip, before we do the peel ply and breather on this side and bag it. Let's take a walk around the shop and see what else is going on right now. In the foreground here we have a milled blank for a 505. It's been milled one side and is ready to flip over. Also, in the background is a new tiller being vacuum bagged down to its form. Over here we have a rudder for an MX Ray with a custom composite headstock on it. Here's another look at the headstock. This is all in primer at this time. Over here we have a new rudder post for a 35-foot boat under positive pressure in its mold. In the spray booth, because we did it with vinyl ester, which is a bit smelly, we have a molded steering pedestal. And finally we have a blank being glued up, red cedar with foam leading and trailing edges that will be turned into another dinghy rudder. The peel ply and breather and vacuum bag are now placed on the new rudder. They're just installing the vacuum fitting. Vacuum hose is attached. We're opening the tap. A lot of air to evacuate out of this bag. Try and make sure the trailing edge is nice and straight as the vacuum pressure comes on. And now we walk away for a day. Here we are the next morning. The vacuum bag has been pulled off. The blade is looking very, very nice. All we have to do is trim the flash and apply the fairing compound. Here's the second side. No wrinkles. With fairing compound, initially we just pour on a clear unthickened epoxy, which gets into the weave and prevents pinholing further down the road. We find that this reduces the number of air bubbles and pinholes that appear. After leaving the unthickened epoxy a while to set up, we now do a thickened epoxy-based fairing compound. Just pour it on and spread it out as smoothly as possible with trowels. Since there's nothing really to fix on this rudder, all we're trying to do is fill the weave of the cloth. We'll let this set up for a couple hours, flip over onto the other side and repeat. Then we let it cure overnight before sanding. We do a quick cleanup with a random orbital sander after the fairing compound is cured, and then later we'll go over it with sanding boards to make sure the shape is absolutely correct. The final step is to spray the primer. In this case we're using an epoxy primer, and we have the blade supported so that we can shoot it from both sides. Here's our finished rudder, start to finish in a little more than a week. All in epoxy primer at this point. Carbon fiber shaft has been wrapped with glass at the bearing locations. She's all ready to box up and send to the customer. And that is how we build a spade rudder.